We're going to work some more problems in preparation for the semester 1 final review for AP Prep. So on the first one, we are given 2 points, -1, 7, and 3, 2. First, let's find the equation of the line containing those two. So to find an equation of a line, we need point and a slope. We've got a couple of points. So for the slope, we can go y2 minus y1 over x2 minus x1. So that looks like it's going to be 5 over -4, or a -5/4. Then we can pick either one of those 2 points. So we could write either y minus 7 is equal to -5/4 times x plus 1. That would be a correct answer. Or y minus 2 equals -5/4 times x minus 3. Those are equally acceptable. So there's a couple of equations of that same line. Now, the exponential function we're going to use as our kind of formula is going to be y equals ab to the x. So plugging in the -1 and the 7, we're going to get 7 is equal to ab to the -1. And using q, we'll get 2 is equal to ab to the third. So I want to divide these, but I'm going to use the larger exponent on top. So I'm going to divide and put the 7 equals ab to the -1 underneath it. You don't have to do that. Now, when we divide, the a's will divide out. That's the good news. We're going to get 2 7s on the left side of the equal sign. When we divide the b to the third by the b to the -1, we're going to subtract exponents, and 3 minus -1 is going to be 4. So we have b to the fourth is 2 7s, so we can raise that to the 1/4 power. And I'm going to grab my calculator and do that. And that looks like we're going to get 2 divided by 7 raised to the 1 divided by 4 power. So I'm getting 0.731. I'm going to write down just 3 decimal places, but I'm not going to use that in the next computation. So now I'm going to go to the equation. I'm going to say 2 is equal to a times b, which we're saying is approximately 0.731 to the third. So the a is going to be 2 divided by 0.731 to the third. And again, I'm not going to use the rounded number when I punch it into my calculator. So I'm going to go 2 divided by, I'm going to up arrow and capture all of that 0.73111,044 and so on. And then I'm going to raise that to the third power, and I'm getting 5.118. 5.118 rounded to 3 decimal places. So then we're going to say our equation is going to be the a, 5.118, times b, which we said was 0.731, to the x power. So there's our exponential. Okay, let's see what else we've got here. So let's find the average rate of change for f of x equals 1 over x minus 2 between x f of x and x plus h f of x plus h. So this is a little bit of an upgrade in difficulty from what we've done before. So the f of x plus h, we're going to take the f of x plus h minus f of x all over the x plus h minus x. Now the f of x plus h means we're going to plug in x plus h into our function f. So that's going to look like the fraction 1 over x plus h minus 2. We're going to subtract from that f of x, which is our 1 over x minus 2, and we're going to divide that whole thing by, since the x's will cancel, that's going to be h. Now, we need to, in order to subtract fractions, we need a common denominator. So we're going to multiply top and bottom by x minus 2 on the first fraction, and top and bottom by x plus h minus 2 on the second fraction. So that's going to give us two fractions with that same denominator. It's going to now be an x minus 2 times x plus h minus 2 in the denominator. In the numerator, we're going to have an x minus, I lost my pen there. We're going to have an x minus 2, and then when we distribute that negative sign, that's going to be a minus x, a minus h, and a plus 2. And now this is all being divided by h, which I'm going to write as times 1 over h. Okay, let's see what happens now. Hopefully everything that doesn't have an h in it is going to cancel. And so that x and that minus x will cancel. That negative 2 and that positive 2 will cancel. Then we've got this now negative h over the x minus 2 times x plus h minus 2. And now when we multiply by that 1 over h, we can cancel this h, and that's how we know we're finished. And so our final answer is going to be negative 1 over x minus 2 times x plus h minus 2. That is our average rate of change. Whew. It's kind of complicated. Okay. Now, if the volume of a cube with side length x inches is v equals x cubed, find and interpret v inverse of 27. So to find v inverse of 27, we're going to plug this 27 in as the y value into our function as the dependent variable. So I'm going to say 27 is equal to x cubed, and that means that x is going to equal 3. So that's saying for our function v of x that we have 3 as an x-coordinate gives us 27 as a y-coordinate. That means for our inverse function that 27 as an x value gives us 3 as a y value. So that tells us v inverse of 27 is equal to 3. So that's the find part. And now what we want to do is interpret this. So for the original function, we input a side length and we output a volume. That means for the inverse, we're inputting a volume and we're going to output a side length. So we will say a cube with volume, that's what we started with here, that was our input, with volume 27, and that would be cubic inches. A cube with volume 27 cubic inches has a side length of 3 inches. Okay, there's the interpret part. So we answered both parts of that question. We did the find and we did the interpret. Okay, let's talk about the next one. Now we're told that f of x equals 10 minus 2x cubed. Part A, we want to find f inverse. So we know that if we think of this as y equals 10 minus 2x cubed, we can switch the x and y, and then we can solve for the y. So we can subtract the 10 over. We can divide by negative 2, which we can do one of two ways. We could say x minus 10 all over negative 2, or it would also be okay to write that as negative 1/2 x plus 5. Either way is okay. And then we're going to take the cube root of both sides. So that would give us, with the big fraction part, that might be the best way to do this, as x minus 10 over negative 2. You could also, I'm just going to write it so you can see it, cube root of negative 1/2 x plus 5. That would be okay as well. And if we want to, this is optional, this is just for aesthetics, we can bring this negative up into the numerator. That will change the negative 10 to positive and the positive x to negative, and that looks a little nicer. And that we can call our f inverse of x. And you don't have to do that last part, but it just looks a little bit better. So there's our part A. Now for the part B, we want to show that f of f inverse of x is x and that f inverse of f of x is x. So the first part first. So f of f inverse of x, and you have to tell me that this is what we're doing here, means we're going to take f of our inverse, which is the cube root of 10 minus x all over 2. And so that is going to look like we're going to plug all of that in for the x. So we're going to get 10 minus 2 times, we're going to have 10 minus x over 2, the cube root of all that, whole thing cubed. So that will, our cube and cube root will cancel. And so that will make us now have 10 minus 2 times, and now we have 10 minus x all over 2 because we've gotten rid of the cube root. Now we can cancel the 2's, but remember we still have to distribute that negative sign, so that's going to be 10 minus 10 plus x, and finally we can cancel those 10's, and we have what we wanted, that we have shown that f of f inverse of x is indeed equal to x. Now we're going to go the other direction, so we're going to take f inverse of f of x. So that means we're going to take f inverse of, and what we're going to plug in for x is going to be our whole f of x, 10 minus 2x cubed. So you have to say this part so that I know that you know which is which. Now into the inverse function, we're going to get the cube root of 10 minus the 10 minus 2x cubed all over 2, which is all in our cube root. We can distribute that negative sign, so that's 10 minus 10, that'll become a plus 2x cubed all over 2. That's still, for the moment, still inside the big cube root. We can cancel our 10's, so now we're making progress. So that's now going to look like the cube root of 2x cubed over 2. Now we're free to cancel that 2, and that will leave us finally with just the cube root of x cubed, which is indeed x, and we have done what we wanted to. Okay, I'm going to slide this up, and now we're going to try to do a piecewise function. So we're going to try to graph a piecewise function here. Looks like it has 3 pieces. So the first part is going to be a parabola that opens up. It's going to have vertex at -3, -1. So there's a point on our parabola. It's going to open up, so I know it's going to go up this way. I need to know where to cut it off, so I'm going to plug in -1 for x. -1 plus 3 is 2. 2 squared is 4. 4 minus 1 is 3. So our y value is going to be 3 when our x value is -1, and that's going to be a solid dot because of the or equal to. So we're going to get something that looks like that part of the parabola. Now I'm going to go down to the middle part. This is going to be a straight line. I'm going to plug in the endpoints and make that a line segment. So when we plug in -1 for x, 1 minus -1 is 1 plus 1 is 2. So when x is -1, the function is going to be 2, and that's going to be an open circle. When we plug in +1, 1 minus 1 is 0, so that means we're going to be at 1, 0, also with an open circle, and we'll connect those. So our function is not continuous at x equals -1. There's going to be a little break in it there. Now we go to the third piece, and that's going to be a parabola, an absolute value, so a v that opens down because of the negative. Its vertex is going to be at 2, 2, so 2, 2 is going to be part of that. I know this is going to open down, so there's the right side of it. I need to know where it's going to end, so I'm going to plug in 1 for x. 1 minus 2 is negative 1. Absolute value of negative 1 is 1. The negative of that 1 is negative 1, plus 2 is 1. So that's going to end at 1, 1 with a solid dot. And so again, we get a discontinuity in our graph. So that does not connect. And there's our piecewise function. Okay, sliding up, looks like we got some exponential problems to work on here. So first we're going to write the 27 as 3 to the third, which is in turn raised to the second. That's going to multiply our 3 to the second to the negative 2. We're going to divide that by 3 to the third, and then we're going to take the whole thing to the 1/2 power, I believe. So 3 to the third to the second, we multiply exponents. That becomes 3 to the 6. 3 to the second to the negative 2 is going to be 3 to the negative 4. And we have our 3 to the third here, all raised to the 1/2 power. So we're going to add the exponents there. 6 plus negative 4 is 2. And we're going to subtract our exponents. So 2 minus 3 is negative 1, and that is in turn raised to the 1/2. So we'll multiply those exponents. We can call that 3 to the negative 1/2 would be okay, or that would be 1 over 3 to the 1/2, which would be 1 over the square root of 3. I'd be okay with that. Or if you want to rationalize it, it would be square root of 3 over 3. I would accept any of those answers for full credit. Let's look at the next one. Now we have to resist. There is no distributive property of exponents over addition or subtraction, so we cannot do this. Instead, what we're going to do is to call this 1/3 minus 1 over 3 squared is 1/9. Wait patiently with that negative 2 exponent. We'll get common denominators, so that's going to be 3/9 minus 1/9 all to the negative 2. That's going to be 2/9 to the negative 2. I like to do the negative exponent separate from the squaring. So the negative exponent is going to take the reciprocal of that. It's going to flip it and make it 9/2. Now we can square top and square bottom and get 81/4. So that's going to be 81/4. Okay, let's slide this up a bit. So now we're going to distribute this, and the 2 multiplies the 1 to become 2. We add our exponents, so negative 1/4 plus 9/4 is 8/4, which is 2. 2 times the negative 3 is a minus 6. We add the exponents. Negative 1/4 plus 5/4 is 4/4, which is 1. These are not like terms, so we're going to stop right there. The next one, we can say that to get out of this first logarithm, we'll go 16 to the 1/4 equals this logarithm. So we have 16 to the 1/4 is equal to the log base 3 of x. Now 16 is 2 to the 4th. Raised to the 1/4 is going to be just 2. So we now have 2 is equal to the log base 3 of x. We'll do the same thing. 3 to the second is x. And so that means that x is going to be 9. Okay, I'm going to slide this up again. So now we have some of our special triangles. We can see that first triangle on the left is a 45, 45, 90 because this is isosceles. So we know that in the 45, 45, 90, the side lengths go x, x, and the hypotenuse is x squared of 2. So if we solve x squared of 2 equals 6, we'll divide by the square root of 2. We can rationalize that, which will simplify to be 3 square root of 2. So that means this side length right here is going to be 3 square root of 2. Now, in the 30, 60, 90, our side lengths are going to go x, 2x for the hypotenuse, and this long leg is going to be x squared of 3. That means x squared of 3 is equal to our 3 square root of 2. To solve that for x, we're going to have to divide by the square root of 3. We'll need to rationalize this, and we can multiply the insides of those. Whoops. It's my left-handedness coming to play on my iPad here. So in the numerator, we're going to get 3 square root of 6 over 3 in the denominator, which will simplify to be square root of 6. So that's saying that x is square root of 6. X is our m, so that tells us that m is the square root of 6, and our n is 2x, which makes it 2 square root of 6. So there's our m and n. Okay, on the next one, we want to show that f is odd, even, or neither. To do that, we're going to plug in negative x for x. If that turns out to be the same as f of x, that means our function is even. And if when we plug in a negative x for x, we get negative 1 times the original, that's going to be odd. And if it's neither one of those, then the function is neither even nor odd. So again, we're going to plug in a negative x. So that is going to be 4 minus 3 times negative x squared. Now we're just going to simplify. So the negative x squared is just x squared. So that's going to be 4 minus 3x squared. That looks exactly the same as our f of x, our original. And so we see that f of negative x is equal to f of x. That means f is in fact even. So if we do this on the next one, we'll plug in negative x. That will become a negative x cubed minus 6 times negative x. So a negative x times itself 3 times is a negative x cubed. Negative 6 times negative x is a plus 6x. Now if we look at that, it is not identical to the original, and it is negative 1 times the original. So that is, in fact, the negative of f of x, and that's what it means then for f to be odd. And on the third one, if we plug in on negative x, we'll get 2 times negative x minus 5. So that's going to be a negative 2x minus 5. Now that is not exactly the same as the original, but neither is it negative 1 times the original, and so we will say f is neither odd nor even. Okay, let's slide up, and we're going to draw theta equals a negative 18 pi over 7, and then we're going to find and label its reference angle. So let's see. We start with the positive x-axis. There's our initial side. Negative means we're going clockwise. So I'm going to think of this maybe as a mixed number. 7 goes into there twice. So that's like a negative 2 and 4/7 pi. So here is a negative 2 pi is one full circle. Now, if I went all the way to here, that would be a negative 3 pi. So 4/7 is going to take me somewhere over here into quadrant 3. And so this is going to be the terminal side, and this is our angle theta. Now our reference angle is going to go to the nearest x-axis, and so we know that if we went all the way to here, that would have been a negative 3 pi. So if we take the 3 pi minus that 2 and 4/7 pi, that's going to leave us with a 3 pi over 7. So our reference angle is this angle that we see in the green, this one right here, and that's going to be 3 pi over 7. Remember, our reference angle is always positive, always acute, and always goes to the nearest x-axis. All right, let's see if we can now find the complement and supplement of theta equals 3 pi over 8. So the complement is going to be pi over 2, that's like a 90-degree angle, minus our 3 pi over 8. If we get a common denominator, pi over 2 is 4/8, minus the 3/8 is going to be 1/8, or a pi over 8. There is our complement. Our supplement is going to be pi minus our angle, 3 pi over 8. Pi is equivalent to 180 degrees, so we're going to get 8/8 minus the 3/8 is going to give us 5 pi over 8 is our supplement. So there's our complement and supplement. Okay, next we're going to look for one positive and one negative coterminal angle for theta equals 8 pi over 7. So a coterminal angle is going to be an angle that has the same terminal side. I'm going to draw you a picture, but it doesn't really matter. We can do this without the picture. 8 pi over 7 is going to be like 1 1/7. So 1 pi is going to take us to that straight line, and so our 8 pi over 7 is going to be down here in quadrant 3. To get a coterminal angle, we can take our theta and just add 2 pi to it. That is, we'll go around the circle once and then end up in that same place. So if we get a common denominator, that's going to be 8 pi over 7 plus 14 pi over 7, and so that'll be 22 pi over 7. That's a positive coterminal angle with our angle theta. A negative coterminal angle is we can back up and go the other way and end up the same thing, to the same place. So that's going to be 8 pi over 7 minus 2 pi. So that's going to be our 8/7 pi minus 14 pi over 7, and that's going to be a negative 6 pi over 7. So that's going to be our negative coterminal angle. That's going to end up being this angle right there. Okay, let's see if we can find the coordinates of a point on a circle with radius 6 determined by theta equals 2 pi over 3. And we're going to say here it's centered at the origin. I didn't say that, but that would make a difference if it was centered somewhere else. So if we look at, say, here's our xy axis, and our circle is going to be a radius of 6. So this distance there is going to be 6. And we're looking at a point that's at 2 pi over 3 over here. We want the coordinates of that point. If we drop in that perpendicular, we know that the x-coordinate of that point is going to be the adjacent side, and the y-coordinate of that point is going to be the opposite side. So we can see, and our hypotenuse, of course, is going to be 6. So we can see that the sine of that angle theta is going to be the opposite over the hypotenuse, or that means that y is going to be 6 sine theta. And since our theta is 2 pi over 3, we're going to get 6 times the sine of 2 pi over 3. Now this we actually know from memory, or we're trying to know it from memory. Otherwise we could use our calculator, but this we can get the exact value. So our reference angle right here is going to be pi minus the 2 pi over 3. Our reference angle is pi over 3. So that takes us back into quadrant 1, and we know the sine of pi over 3. Let's see, the sine, pi over 3, we go 0, pi over 6, pi over 4, pi over 3. So we're going to be 4 clicks. A sine starts small, so it's going to go 0, 1/2, 0, 1/2, square root of 2 over 2. That's going to be square root of 3 over 2. And in quadrant 2, sine is positive, so that's going to give us 6 times the square root of 3 over 2. And so that means our y-coordinate is going to be 3 square root of 3. And our x-coordinate is going to be cosine theta is going to be x over r, which is x over 6. So that means x is going to be 6 cosine theta, which is going to be 6 cosine of 2 pi over 3. So that's going to be 6 times, now the cosine of 2 pi over 3, same reasoning, our reference angle is pi over 3 in quadrant 1. Cosine starts big, so we're going to go 1, square root of 3 over 2, square root of 2 over 2, 1/2. And in quadrant 2, cosine is a negative, and so that is going to give us a negative 3. So the x is going to be a negative 3. And so the coordinates of that point where our angle intersects that circle of radius 6 is going to have an x-coordinate of 3, negative 3 rather, and a y-coordinate of 3 square root of 3. Okay? All right, let's see if we can do a little graphing and remember all of our stretching and shrinking and reflecting. So a square root of x, remember a square root of x curve is going to look something like this. And it's going to contain the point 0, 0, and it's going to contain the point 1, 1. So let's first talk about our reflections. This is going to reflect it in the x, and that is going to reflect it in the y. So here's a reflection in the x, in turn reflected in the y. We're going to be talking about going down and to the left. Now our starting point is going to be that 0, 0 is going to be at negative 1, negative 1. So we're going to be right there is going to be a point on our curve, negative 1, negative 1. Now this 3 is going to be a vertical stretch, and this 1/2 is going to be a horizontal stretch. So instead of going as we would if it wasn't stretched or shrunk, instead of going down 1, left 1, we're going to go down 3 and left 2. And that's going to give us our second point that's going to have x-coordinate negative 3 and y-coordinate negative 4. And it's going to be this bottom half of a sideways parabola opening to the left. Okay, now let's see what we can do with graphing a sine curve. So we're going to need here to factor the pi over 2 out. So this is going to be y equals negative 3 sine, and then if we take out the pi over 2, then that's like dividing by pi over 2, which is going to multiply by the reciprocal, so that's going to be a plus 1/2. So our period, we know, is going to be the natural period 2 pi divided by what's multiplying the x, the pi over 2. That's going to be 2 pi times 2 over pi. It's going to be 4. So what I like to call critical points, where our spacing between tick marks is going to be our period divided by 4 is going to be 1. Okay, I keep bumping this with my left hand. So our amplitude here, let me bring my pen back. Our amplitude is going to be the absolute value of -3 is 3. Okay, so we're going to translate this vertically up 1. So that's going to be our midline here. It's going to be the middle of our graph. Since our amplitude is 3, I'm going to put a boundary for the top of the graph that's 3 above our midline. So I guess that's going to be at 4. And there's our midline. And I'm going to go down 3. That's going to be the bottom of our graph, which is going to be at -2. Okay, so our starting point is going to be at -1/2. So I'm going to call this -1/2. Our tick marks are going to be every 1. So if I go over 1 from -1/2, that'll be +1/2. And then trying to keep my spacing, another 1 from there will be 3/2. Next will be 5/2. That'll be 7/2. Let's see, it's 1, 2, 3, 4. And that's going to be 1 full period. Now sine starts in the middle, so we're going to put our curve here in the middle, right there. Because we have a negative sign, it's going to go down first, then back to the middle, up to a high point, and end back in the middle. And so here is our reflected sine curve. Okay, now finally we're going to go the other direction. Let's see if we can find an equation of a sine or a cosine curve where this is a maximum value and this is going to be a minimum. So first we have to decide we want to call this a positive or negative sine or cosine. So I'm going to think of it as starting here. That's going to be starting at a high point, which means we're going to be calling this a positive cosine curve. Because it is starting at pi over 6, then that means we're going to have an x minus pi over 6 is going to show our translation vertically. Now we can see our amplitude is going to be the maximum minus the minimum divided by 2. So that's going to be 14 over 2, which is 7. And that amplitude is going to be our A. So we're going to plug a 7 there, and we said it's a positive 7. So I'm going to leave that as a positive 7. Now the midline then is going to be our translation vertically. So we're going to add our amplitude, or our stretch, that's 7 to the low point, or subtract it from the high point. So adding 7 to 1 is going to make that be a +8 over here. And always the hardest part is figuring out what this b is right there. And so b, remember, is going to be our natural period, which is 2 pi, since we're in radians here, divided by our actual period. So we're going to have to figure out what is our period. So the horizontal distance between the high point and the low point, remember, is going to be half of a period. So 2 pi over 3 minus pi over 6. See, that's going to be 4, 6 minus 1, 6 is going to be 3 pi over 6, which is pi over 2. That's half a period. So the actual period is going to be 2 times that, which is pi. So our period is pi, and that means our b is going to be 2 pi divided by pi, which is going to be 2. And that tells us to put a 2 there. This is one, but not the only correct answer to that curve. All right,